Okay, I am Sahil and I will be explaining the Kruskal algorithm. Now, what is a minimum spanning tree? A minimum spanning tree is a collection of edges that includes every vertex in a graph and but do not form a cycle. And the weight of a spanning tree is sum of the weights given to each edges. Now, what does that mean? Now you can see this is a graph and this is a spanning tree. Now, the spanning tree contains all the vertices of the graph, that is A, B, C, D, E. It also contains A, B, C, D, E. But the spanning tree do not form a cycle. So this is a spanning tree. It do not form a cycle and it contains all the vertices of the graph. That is from A to E. Now, what is the Kruskal algorithm? Now, it is used to discover the shortest path between the 2 points in a weighted graph. Now, as you can see, this is a graph. Now, consider 2 points A and B. Now we have many paths to move to the point E from B, but we need to select the shortest path between B and E. So that is done using Kruskal algorithm. So let's see what are the steps involved in Kruskal algorithm. So the first step is we need to sort the edges in an ascending order. The second step is we need to the edge with the minimum weightage is to be chosen, and we need to see whether it forms a cycle or not. If it forms a cycle, we need to discard it, and if it does not form a cycle, we include it. So let's see with an example. Now this is a graph. So the first step is to arrange in ascending order. So we need to arrange this in an ascending order as we have arranged it here. Then we take the minimum weighted edges, that is AB, we place it here. Then we go for second one, DE. First we need to check whether it forms a cycle or not. So it does not, because there are only two edges. So we place it here. Then we go for BC. So it also does not form any cycle. So we add it. Then we go for CD. It also does not form any cycle. So we add it here. Then we go for next one, AE. Now AE. If we add AE here, it forms a cycle. So we discard AE. Then we go for next one, AC. Now AC also forms a cycle, so we discard AC. Then last we move on to AD. Now AD also forms a cycle, so we discard this also. So at the end we get the minimum spanning tree. This is a minimum spanning tree, and to find the cost of a minimum spanning tree, we add all its edges from AB, that is AB, BC, CD, and DE. So the final answer we get is 10. So this is the algorithm of Kruskal. So the code will be explained by my friend Satvik.
Hello everyone. I am going to explain the Kruskal algorithm Java program. My name is Satvik, and now let's start with the program. In the beginning, let's start with the main program. Here we have declared a matrix of maximum size 10 into 10. Basically, this matrix represents the weighted graph. We can see here this is the weighted graph, and we have declared I and j, and this I and j is used to keep the track of the row and column. System.out.println enter the number of vertices of the graph. To enter the number of vertices, we are using a scanner function. Here n is the number of vertices of the graph. In this example, we are taking the number of vertices as 5. And with the help of two for loop and I and j, we are entering the vertices of the graph. We are entering the weights of the graph. Here, Kruskal K is equal to new Kruskal. Kruskal is a class and K is an object. Here we have created an object K which is an instance of the class, and we are calling k.krkl an. This is the void krkl. This is a function declared. Now we have declared, we have initialized u to 0 and v to 0, and we have declared min. Min variable. Min variable is used to store the minimum element of the two-dimensional matrix, and we have taken k. This is basically used to keep track of the nodes, and this is initialized to 0. And we have taken another variable I and j, and finally we want the cost of the matrix. That is why we have taken sum, and it is initialized to 0. Now, while k less than n minus 1, here we have taken n as 5. So, n minus 1 is nothing but 4. K means 0, 0 less than 4. Is it true? Yes, it is true. Minimum is equal to, min is equal to 99. So, here 99 gets stored in min variable. And now we must see the array. This is the array. This is the two-dimensional matrix. For I is equal to 1, I less than equal to n, I plus plus, j is equal to 1, j less than equal to n, j plus plus. Now let's go with the iteration. When I is 1 and j is 1, we enter the loop. If a of I and j less than min and I not equal to j. Here I is 1 and j is 1. So this if loop can never run because I not equal to j condition is false. Next, j gets incremented to 2 and I is 1 and j is 2 now. Now we can see the two-dimensional matrix. Here 3 is the element that is placed in 1 and 2. That is first row, second column of the two-dimensional matrix. So now min is equal to a of ij. That is min is equal to a of 1, 2. Now a of 1, 2 is nothing but 3. So min is 3. Min gets updated to 3. Now u is equal to I. That means the current I value is 1. That is loaded to u. And current v value and current j value is 2 and that is loaded to 2. Next, if loop runs one time now. Now for the next iteration j gets incremented to 3 and again it sees in the two-dimensional matrix I is 1 and 3 is 99. 3 now. I is 1 and j is 3 now. Now a of 1 comma 3 is 99. Now let's check the condition. 99 is 99 lesser than 3. No, this condition is false. Then j gets incremented again. Again, let's see the two-dimensional matrix. 7, 1, 4, 7. Now, is 7 less than 3? This condition is also false. Again, j gets incremented to 5. 99. 99 is not less than 3. So this condition is also false. It never enters the if loop. 3. 3 less than 3. This condition is also false. 0 less than 3. This condition is true. But there is another condition available here. I not equal to j. That means 2 not equal to 2. This condition becomes false. Let me update here. 1, 2, 3. And now we are running the second iteration get false, and 2 comma 3 now. 2 comma 3 is 4. 4 less than 3 is false, so j increments again to 4. Now 2 comma 4 is 2. Now let's check the condition. Is 2 less than 3? Yes, of course, 2 is less than 3. Then let's check another condition. Is 2 not equal to 4? Yes, this condition is also true. Then min gets updated with 2. That is, min is updated with a of 2 and 4. That means min will get updated with 2 now. U is equal to I. That is, U is 2 and V is 4. Let's update here 2 and 4. Now the control comes out of the if loop. Again, j gets incremented to 5, and 99 less than 2 is false. Now minimum is 2. So 2 gets updated as a minimum. Then all this condition gets false. See here 2 is available, but 2 less than 2 becomes false. So I will be 2 and j will be 4 itself. This is a stable. Now 0 is less than 2, but 4 is not equal to this condition will get false. So finally the minimum element available is 2. This is the theoretical representation of the matrix, and this is the graph what we get if we decode this matrix. Now the control comes out of the for loop, and I is equal to find new function is called. Let me delete this thing. Yeah. Okay. Now the control comes out of the loop, and I is equal to find new function is called. That is, I is equal to find u. Now our current value of u is 2. Now the control moves to the find function. Here we are having find function. The current value of u was 2. Now we are passing that 2 to the m. So the m contains 2. Now this m is moved to p. So the value of p is also 2. Now in the initial of the function, that is by initial of the class, we have declared an array called parent, and this parent array is automatically initialized to 0. Now, now this condition is checked while parent of p not equal to 0. The parent of 2 not equal to 0. This condition is false. So now the while loop never executes. Then return p happens and I is returned with 2 here. That means same value is returned back. Same way, j is equal to find v. We pass 4 to the find function and we again return with the same value. That is j becomes 4 now. Now, if I not equal to j, I not equal to j, that is 2 not equal to 4. This condition is true. Then we call union of I and j, that is union of 2 and 4. And we move to union function. Here we passed. Now we are passing 2 here and 4 here. Now we have passed 2 and 4. Now 2 less than 4. Condition is true. Then parent of I is equal to j. This line gets executed. That is parent of 2 is equal to 4. This gets executed. Now let's see the parent function. Parent of 2 is now 0 currently. Now this gets updated to 4. Now parent is equal to j, that is parent of 2 is 4 now. Next, again we'll return back system.out.println u plus v is equal to a of u comma v. Now we know that a of 2 and 4 is 2. Now this gets printed out and sum is equal to sum plus a of u comma v. Sum was initially 0 and this gets added up to 2 and k is incremented. K plays a very important role in this program. Consider initially k was 5 and when one node is visited, I mean consider initially k was 0 and when one node is visited then k gets incremented to 1. This process takes place until k is less than 5. That means all the node is visited. So this is the importance of the k in this program. Next, we are updating a of u comma v and a of v comma u to 99. This is to make this is to indicate that we have already visited 2 and now we don't want 2 as the minimum element. So we will update this position as 99. And next minimum element is found out in the program. So a of 2 comma 4 and a of 4 comma 2 is equal to 99. So a of 4 comma 2 is this. This position is also taken as 99. Now we don't want 2. Next we will go to 3. The same way all the nodes will be visited. Finally we get a spanning subtree, that is this tree. Initially 2 will be visited, and and now the minimum edge present is 2 here. So 2. Next we visit 3 here. 1, 3. 3 is the minimum edge present. See, 3 is the minimum edge present. Next that will be visited, and that will also be updated to 99. And the next largest edge is 4. Then 4 will be visited. Again we are having another 4 here. Even that 4 also will be visited. Now again we are checking with 5, but 5 cannot be included for the subtree, because 5, if 5 is included fifth edge, then it causes a cycle, and this is against the Kruskal's theorem. So this is the final spanning subtree we get, and the total cost is 4 plus 3 plus 2 plus 4, and the sum is 13. Let us run the program, and I will display the program. Let us enter the weighted matrix, and this is the answer. The cost of the minimum spanning tree is 13. Thank you very much.